Let's look at this problem here. We have the function, the graph of the derivative given, and they are asking you to fill in the following blanks based on the points that's given to you. So because this is a derivative given, so being positive means the original function is increasing, and being negative means the original function is decreasing. So I'm looking for where the function has the largest value. So first of all, those are all where the derivative are above the x-axis, therefore they are all positive derivative. So my function would be keep increasing all the way through until I reach to this particular point, after which the derivative is negative, so function begins to decrease. Therefore, the function value at those points is going to keep getting larger and larger and larger. Therefore, the one with the largest function value is the last one before I reach here. So this must be having the largest function value. Therefore, the least function value must be the one at the left side because, again, my function keeps increasing, right? So the left one must be having the smallest function value. Well, when I try to find out where is the function having the greatest, it says the derivative is largest. This is a graph of the derivative, and I'm looking for the largest value on this graph. Therefore, I'm looking for the highest one, which is this particular point. So my answer is supposed to be E. The next thing is where the derivative is the least. So I'm looking at all those points that's given to me. This is the one with the lowest height, which means it's the lowest of, this is the graph of derivative, so it's the smallest derivative, so that's supposed to be C. And I'm looking for the derivative being the greatest, second derivative being the greatest. This is the first derivative. Then second derivative is the derivative on this graph. So I'm looking for at which point the derivative of this graph is going to be largest. So this is increasing. So the derivative of this, namely second derivative, is positive. This is decreasing, so negative. This is roughly speaking 0. This is increasing, so positive. This is 0. This is decreasing, so it's negative. So I'm only looking at those 2 points, and this one increased like that, this one increased like that. Clearly, this is a faster increasing piece. So my derivative of this function, namely second derivative of the original function, is the largest at the point of D. Along the same line of thinking, I'm looking for the smallest one. The second derivative is the least. So I'm looking for the negative values. This is decreasing like that. This is decreasing like this. So it's clearly more dramatic going down. So it's more negative. So this point has the smallest, because it's most negative, smallest second derivative. So that's supposed to be my answer for this part. And that gives us the answer for all the problems in all the